Today I'm going to talk about a variation of wind power. Kite generators. So these systems use wind to generate electrical power. And the typical system uses two kites that basically look like parachutes. These kites are attached to spools in the main body, and these spools are wound up with a cable connected to the kites. These kites are pulled by the wind, and as they're pulled, the cable is unwound and the spools rotate, and these spools drive a generator to generate electrical power. So an important part of these systems are what's called hydraulic accumulators. These hydraulic accumulators store potential energy in the form of pressure. Their main objective is to smoothing the irregularities generated by the different kite speeds, allowing for a stable output of power. So if we were to look at this in a power to time graph, the normal power outputted by the kites without the hydraulic accumulator would look something like this. While if we use hydraulic accumulators, it somewhat looks like this, which is linear or constant. This is very important when outputting power to the grid. The general function of these systems is that when one kite is risen with the wind speed, the other one is lowered. And some of the energy that we obtain from the rising kite is used to wind the spool of the lowering kite. While this spool is being wound and the kite is being lowered, the kite is retracted. So if this is the first state of the kite while it's being risen, it's retracted into a smaller version. So the area that faces the wind in the second case while it's being lowered is lower than the area while it's being risen. This means that less energy is needed to wind the spool of the second kite, meaning more power being generated into the grid. Some of the benefits that come from these generators compared to the usual wind turbines is, first of all, higher altitudes, which in turn mean higher speeds. Higher altitudes are achieved since there's a lot of flexibility from using cables. The other benefit from these systems is that they can work under hurricane speed winds. So that means that these systems either won't break or won't have problems when they face these types of winds. Very different from normal wind turbines, which usually have to be turned off for these kinds of wind speeds because they can't withstand these forces. The next benefit involves the ratio of dollar per megawatt of power generated. These systems can generate 1 megawatt for about 1.5 times less money than the usual wind turbine. And last is that these systems can be deployed very quickly, at least in a day, which means that they can be very useful for sites where they have faced a natural disaster and they have lost their power grid.